Hello everyone. So in this video, we are going to be talking about alkenes. So we know what alkenes are. Alkenes are all the hydrocarbons that happen to have a double bond in them. Now your molecule could just have one double bond, or it could have multiple double bonds. So we'll take examples. We'll learn their nomenclature. We'll see how they're named. And then we will talk about their chemical reactions, okay? Um, so to get started, guys, let's talk about its nomenclature. So we'll start with a very simple example. We'll take a structure which has a double bond on it. So what you're seeing here is it's a hydrocarbon. So just like we have done alkanes, what we always do, we look for the longest chain. In this case, for alkenes, so whenever you have a double bond, or for the matter of fact, even if you have a triple bond, um, whenever you have double or triple bond, they must be included in your parent chain, okay, even though it does not form a longest chain, okay? So most of the times you will see the longest chain has double bond, but you also make sure that the double bond is getting the priority and it must be included in the parent chain. Okay, all right. So what do you see here in this example? You see that you have 1, 2, 3, 4 carbons. This is 4 carbon long. So we know that this is going to bute because bute is the root name for 4 carbons. Now, for alkanes, we used to call them butane if we had 4 carbon. Since this time you have an alkene, we are going to be calling this butene, right? Now, if you just call this molecule butene, you're telling me that it has 4 carbons and there is a double bond, but then you're not telling me where is that double bond situated, right? Because that double bond could just have been sitting here between number 2 and 3, right? So we need to make sure we tell where is the double bond. So wherever the double bond starts, that's the carbon number you take, okay? Since the double bond is between 1 and 2, it's a smaller number where you start, okay? So it's a 1 butene. Now, there's another way to write the same name. And guys, you want to make sure you understand that as well. We should be aware of both the ways to write the name. So guys, we can actually bring this 1 in front of the ene to be very specific that this 1 belongs to the ene. So what we do for that is we say but dash 1 dash ene. So this is very explicitly saying that this 1 belongs to the ene. Okay, so when you're going to have, more first names, then actually this will be easier, it'll just be more visual and less confusing. Okay, now, so again, both are the accepted ways to write, and we should know both of them. Okay, all right. So now let's take some more examples. Um, let's say we have this molecule, and this molecule happens to have 2 double bonds this time. So what would this be called? So let's try that. First of all, since this guy has 2 double bonds, this comes under the category of dienes. Okay, so the previous example, this was just a normal alkene. The second one, this is also alkene, but to be more specific, it's a diene because di means 2 and ene means double bonds, so there are 2 double bonds. Now, if you see a word polyene, what would that mean? What do you guys think? Polyene will be something that has many more double bonds. Okay, all right. So for this example, what do we do? How do we name this? The longest chain we can tell is 1, 2, 3, 4, 5 carbons, but should we name this from left to the right or right to the left? What do you guys think? Pause the video for a second and tell me, where do you think the number should start? Should start from left or right? Okay, so what I see here is, again, you want to start the numbering where the double bond gets the smallest number, right? So if you start from the left, this is how numbering will look like, and the numbers you will be getting for the double bond will be the 1 and the 3, right? That's where the two double bonds start, at 1 and 3. On the other hand, if I had started numbering from the right hand side, then I'll be getting 1, 2, 3, and 4. So I'll be getting 2 here and a 4 here, which is definitely not as good as 1 and 3. So this is the numbering you keep. So since you have 5 carbons, we know that this is going to be called pent because we have 5 carbons. Now this will be a diene because you have 2 double bonds. So pent, and then where are those 2 double bonds? Double bond is at 1 and 3. So pent dash 1 comma 3. You guys remember whenever there's a name and a number, you put a dash. And when you have 2 numbers next to each other, you put a comma. So pent dash 1 comma 3 dash diene, right? So again, you guys see that we're putting this number right in front of the diene to be very particular that the 1 3 belongs to the diene and nothing else. Okay, all right. So if we had to name this the other way, where we had the number in the front, what would that be called? You'll just bring 1 comma 3 in the front dash pentadiene. Okay, just keep one thing in mind. Here you don't see the A, here you do see the A. So again, whenever you're bringing, 2 words together, uh, and you need, a vowel in between. So you have a consonant and a consonant. So you need a vowel in between. That's where you're adding that A. Okay, so pentadiene. All right. Now let's do some more examples here. So let's say we have a structure which looks like this, and there happens to be a double bond here. And there happens to be a substituent here as well. Now, in this case, what do we do? Okay, so now again, the way you are going to number this is so that you get the smallest numbers possible, right? Now, if I number this from left, I get 1, 2, 3, 4, 5, and 6. On the other hand, if I start from the right hand side, the numbering will look like this: 1, 2, 3, 4, 5, and 6. So the black ones, the numbering from the left hand side is giving me 2 for the substituent and 3 for the double bond. So that's a 2 and a 3. So let me write that down. I get a 2 and a 3. If I do the red one that starts from the right hand side, my double bond still gets the 3, but the substituent gets the 5. So we know that 2 3 is a better combination than 3 5. So we are going to keep the numbering from the left to the right. So let's remove all the red numbering. We won't confuse ourselves. Okay, so now let's answer this, guys. So this should be pretty straightforward now. You guys can pause the video and then tell what the answer should be. Okay, so let's see. So again, you have 6 carbons and a double bond. So this guy is going to be a hexene, right? So we have a hex for 6 carbons. And then again, 2 options. Since the double bond is at number 3, you can call it 3-hexene, or you can call it hex 3-ene. Both are totally okay. So hex 3-ene, right? And then in the front, what do we put? We need to tell that we have a substituent. What is this substituent? This substituent is called methyl. So you have a methyl sitting on carbon number 2. So it's simply 2-methyl hex 3-ene, or you could have said 2-methyl 3-hexene. Both are totally fine. Okay. All right. Now let's do some more examples. Let's see if we have something like that, where we have double bond sitting here, then maybe a double bond sitting here, and then we have a substituent sitting here. Okay, so let's take an example like this. Again, pause the video and then try to number this molecule. So try that. Find the longest chain and try the number. Okay, so what do we see, guys? We can see in this example, if we start from the left-hand side, you will see the numbers we're going to get will be 1, 2, 3, 4, 5, 6, and 7. If I was starting from the right-hand side, I would be getting 1, 2, 3, 4, 5, 6, and 7. So we got to tell which one is a better numbering. So if you look at the blue ones, our double bond is getting 1. And this double bond is getting a 5. So it's getting a 1 and a 5. And my methyl substituent is getting number 3. So we have 153 or 135. Okay. Now, for the numbering from the right hand side, the red numbering, what do we get? We're getting a 2 for a double bond. We're getting a 5 for the metal, and we're getting a 6 for this double bond. So 256 versus 153. Definitely, we can tell that the blue numbering is better. 153 is the one we go with. So because 153, of course, it's smaller than 256. If you get confused with numbers like this, you can just add them up as well. 5 plus 3 is 8, 8 plus 1 is 9. So the total here is 9. On the right hand side, if we compare that, 5 plus 6 is 11, 11 plus 2 is 13. So 9 is better than 13. So you can add up the numbers if you ever find them confusing, okay? So we're going to get rid of the red numbering. So let's get rid of that. Okay, so we have the blue numbering, and let's see how to answer this. Okay, so guys, again, your first job is to get the last name, and last name come from the longest chain. Your longest chain has how many carbons? It has 7 carbons. So it's hept, right? So hept means you got 7 carbons. Now you need to tell where the double bonds are. The double bonds are at position number 1 and position number 5. So it's hept 1, 5 diene, because we have 2 double bonds. So you've got to use di. And you need to tell the position of both the double bonds, so 1 and 5. Now, what we need in the front is the name of the substituent. What substituent are we carrying? We're carrying this metal, which is sitting on what carbon number? It's sitting on carbon number 3. So you just say 3-methyl hept 1,5-diene. Okay. All right. So now let's keep doing some more examples. So guys, the examples we have seen so far are the ones where the carbon were in a long chain, right? They were branched, but they were not. They were a straight chain. They were not cyclic. So let's take some examples where we have an alkene, but it's inside a cyclic structure. Okay, so let's say there's a double bond sitting here. So how do you name these guys? So guys, if you simply had a structure like this, where you had 1, 2, 3, 4, 5, 6 carbons, you would just call it cyclohexane, because 6 carbons, all single bond is hexane. And since the structure is cyclic, it's called cyclo, right? So for this guy, this is also cyclo. It's still hex because I still have 1, 2, 3, 4, 5, 6 carbons. So cyclohex, but then we have a double bond. And for the double bond, we need to use ENE, so hexene instead of hexane. So guys, cyclohexene is telling me that I have a cyclic structure with 6 carbons and it has a double bond. Now you might be wondering, are we supposed to say cyclohex 1-ene or not? So like, are we supposed to tell where is that double bond sitting? So guys, specifically for this example, there's no need to do that. Why not? Because the idea is that wherever the double bond is going to start in a cyclic structure, that's where the numbering is going to start. So guys, if I number this, let's say 1, 2, 3, 4, 5, and 6, you see my double bond is starting at carbon number 1. So if I call this cyclohex 1-ene, you know, that's the name it's going to get. Let me draw this structure again, but this time I am going to put, let's say, a double bond over here. Let's see if that makes any difference. Okay, so let's see how should the numbering for this one work. The idea is the numbering for this will work the exact same way it worked for this one, for its example. Because what does the rule say? The rule says that the numbering is going to start where the double bond starts. So double bond, if it's, let's say it starts here. So if it starts here, that's the 1. Let me get the different color. So if this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. You see, this structure is actually the exact same structure like this one. These two are exact same identical structures. We have just drawn them at a different orientation. So if you were going to just say, if you're just going to flip this molecule onto the right-hand side, you would see you'll get the same structure. So it's the exact same molecule that you're dealing with, That's why there's no need to actually call this hex 1ene, because in a structure like this, wherever the double bond is, that's where the numbering will start. Okay. All right. Let's see some more examples, which look a little different. So guys, imagine you got a cyclic structure again, but this cyclic structure happens to have 5 carbons, 1, 2, 3, 4, 5 carbons, and it has an attachment here, and it happens to have a double bond here. Okay, so now in this case, how do we do the numbering? So we understand we have 5 carbons. We also have a substituent. The substituent is sitting right here, and we have the double bond. Now, how should we start the numbering? Who should we give the priority to? Should we give the priority to the double bond, or should we give the priority to the substituent? So we have learned that already, that the priority should go to the double bond versus any substituent. So double or triple bond, they have a higher priority over a substituent. Okay, and we'll learn later between double and triple bond, if there's a tie for numbering, then double bond gets the priority. Okay, but so right now we'll just stick with what we have in the front. So here, if I start the numbering, guys, let me show you the correct and incorrect way to number this. So if I number this from here, you see wherever the double bond is, that's where we're supposed to start. So 1, 2, 3, 4, and 5. You see your double bond got number 1, and your substituent got number 3, which looks good. Let's see some more ways to number this, which are not correct. Okay, but they might come into your mind that why are we not numbering them like that? Okay, so let's say you number it starting from the substituent 1, 2, 3, 4, 5. You guys tell me what is wrong with this? What is wrong here is that we're giving the priority to the substituent and not the double bond. Okay, so this is incorrect. Even though if you look at the combination, your substituent is getting 1 and double bond is getting 2. So 1, 2 versus 1 and 3. You see 1, 2 actually looks better than 1, 3, but we're not following the rule here, which we mentioned that the double bond gets the priority. So this numbering does not work. Okay, now it might come to your mind and you want to number it a third way, which is also incorrect. So let's take a look on that. Okay, so if I go this way, 1, 2, 3, 4, 5. If I go this way, I'm not following the double bond correctly, because when I will say that it's a cyclopentene and it's a 1-cyclopentene, then the double bond will actually fall between 1 and 2 if I do the numbering this way. Okay, that's why it's incorrect to do the numbering this way. The numbering has to start here from 1 and then go to 2. Okay, if the numbering starts here from 1, and if I go to the top, what will happen in that case? So let's take a look at that as well. So first of all, guys, you see why this is wrong is because you don't want to go away from the double bond. The double bond should be included in the numbering. Okay, so that's one. Okay, so this is also incorrect, right? So let me erase this as well. Now there's one more incorrect way which you guys might think of writing it like. So let's take a look at that. What is that option? So 1 here, and then 2 here, 3 here, 4 here, and a 5 here. What is wrong with this, guys? You're giving your double bond a 1, which is good. You're giving your double bond a 1, which is good, right? So both those look good. But then your methyl here is getting number 5. So 1 and a 5 combination is not as good as the 1 and the 3 combination. So guys, again, the direction is making that difference in how you number. So you have to number this 1, 2, 3, 4, 5 instead of numbering 1, 2, 3, 4, 5 like that. Okay, because here you're getting 1 and 3, which is better than getting 1 and 5. So this is not good. So I'm going to be removing this number from here. All right, so now let's go back to naming this molecule. So what will the answer look like? So let's work on that. So guys, we have a cyclopentene. So let's write that down. It's a cyclopentene. You can write pentene, or you guys know that you have a double bond sitting at number 1, so you can actually put that in here. So cyclopent 1-ene, right? And then Again, you could have skipped that numbering as well. You could have just called it cyclopentene because it's very obvious that a double bond is starting at number 1. So you could have just simply called this cyclopentene, and that would be okay. So cyclopentene like that, okay? Now, where is the metal sitting? The metal, the substituent, this metal is sitting at number 3. So it's a 3-methyl cyclopentene, okay? I hope that is making sense, okay? All right, now let's take an example where we have a molecule very similar, but this time we have 2 double bonds, and then we have a bromine that's sitting here, okay? And in this case, what do we do? How do we do the numbering first of all? So guys, remember we want to start the numbering such that the double bond is included in the numbering, as in when we say 1, 2, 3, 4, if the double bond, we want double bond at 1, then you have to move with the double bond, and the carbons between the double bonds are the ones which should get 1 and 2. Okay, so let's see, what do I mean by that? So guys, to number this, what do you want? You want that both the double bond gets a smaller number, and at the same time the bromine substituent also gets the smallest number possible, right? So I can see, let's try different ways to number this. So you can pause the video and try it yourself if you want to number this different ways, and then find out what will be the correct answer, okay? So you can pause the video here if you want. Okay, so if I number this 1, 2, 3, 4, 5, and 6, this is not good. Why is this not good, guys? Because my double bond is getting 1 and 4, which is okay. But then the bromine is getting 6. So I'm getting 1, 4, and 6. That's the combination that I'm getting. If we were to number this, you know, if we get started from here, 1, 2, 3, 4, 5, 6. That's one option. We can also, I'm sorry. If I start from here, 1, 2, 3, you see what is wrong? When I say 1, 2, 3, I'm not including the double bond in the numbering. So 1 and 2, if I say that, then the double bond has been left behind. So you don't want to go that way, okay? What is another option? Another option is that let me remove this numbering. So this was 1, 4, 6. So let's get rid of that for right now. The other possibility is that I start numbering from here, 1, 2, 3, 4, 5, and 6. In this case, what are we getting? I'm getting 1 for my double bond and 4 for my double bond, which is good. 1 and 4, which is similar to the numbering we did earlier. But then the bromine is getting 3. So you guys see how by just switching this direction, so instead of going 1, 2, 3 downwards, we should actually go towards the substituents, and that will actually give us the smaller number for the substituent. Okay, so 1, 4, 6 is definitely not as good as 1, 4, 3. So we want to go 1, 4, 3. So we will go with the numbering with this numbering we did later on. Okay, so let me remove this numbering from here. So 1, 4, 3 is the way to go, right? So let's see how do we name this? So guys, we have 2 double bonds. So this time for sure we'll need to give the numbering to the double bond. So this guy is going to be cyclo. It's a cyclohex because you have 6 carbons. Cyclohex, and the double bonds are 1 and 4. Okay, so cyclohex 1, 4 diene, right? You could have also called this 1,4-cyclohexadiene. So let me write that down as well for you. Cyclohexadiene. Remember, guys, whenever you're bringing diene and hex together, you have to put an A in between, okay? So 1,4-cyclohexadiene. So that's, again, the last name. Now, what goes in the front, guys? What is our substituent? Our substituent is bromine. And whenever you have any halide, like a bromine, as a substituent, you call them, you add the O at the end. So bromine becomes bromo. Chlorine becomes chloro, okay? So Br is called bromo. Now you put that bromo here in the front, so bromo cyclohexone for diene, or you put that here, bromo dash 1,4-cyclohexadiene. And then for the bromo, the position is number 3. It's sitting at 3, so 3 dash bromo, 3 dash bromo. Okay, so both of those names are correct, and I hope that is making sense. Okay, all right. Now, when it comes to the double bonds, we have to learn one more thing about the alkenes, which is the cis and the trans configurations. Okay, and we'll talk about that in our next video. Okay.